explain you my 7th experiment in Unix and Linux Lab. So this experiment is on file operations using system calls. So the first question is to write a C or C++ program to copy the contents of one file to another file using Unix system calls. So I have used my CPP here. So this is my first program. So in this file I have used an array of 100 size called buffer, and fd1 and fd2 for file descriptors 1 and 2 respectively, and I have another array of characters for file name and f2. So here I'll be getting my file name, and then I'll be opening that file in read only mode, and if my file descriptor returns -1, in that case and display file does not exist. If my file exists, I will do these operations over here. So first of all, I will read my fd1 buffer 100, then I will print the contents of the file, initial whatever the contents are there, then I will print my new file name, which is f2, and then I will be creating it, and I will creating it and storing the file descriptor in fd2. So for creating, I will be using the create system calls that is create f2, 0761. So 0761 are the file permissions, 0 is for no permissions, 1 is for read, 1 is for execute, 2 is for write, 3 is for execute and write, 4 is for read and write, 5 is for read and execute, 6 is for read and write, and 7 is for all permissions. So I have used 0761, a combination of no permissions, all permissions, then 6 for read and write, then 1 for only execute permission. So it is an octal permission representation. Then I will display my contents of the new file as again with the read system call read fd2, that is my file descriptor, second file descriptor, array of characters with the size. Now let's check our output. So my file name is hello.txt. So before moving to the file name, let's check what all there are contents in my hello.txt file. So initially my hello.txt contains hello welcome, and my this is my hello2.txt file. So you can see the thank you is present. Now I'm going to execute it. So enter my file name as hello.txt. This is my first file name. Return my fd. If my fd is not equal to -1, the following operations will execute. Then as you can see, those are my contents. Hello welcome. Enter my new file name, that is hello2.txt. The contents of the new file is hello welcome. Let's have a look on our new file hello2.txt. As you can see here, hello welcome is displayed over here. Moving to the next question. So to write a C++ program to concatenate two files and write it to the third file using the Unix system call. So in the previous question I have used two FDs. So and with that one I'll be copying it to the second one. So this time I'll be using 1 and 2 and concatenating it and storing it in the third file. So this is my code. So I have, as said before, I have 3 FDs, file descriptors 1, 2 and 3, and these are my 3 array of characters, buffer arrays 1, 2 and 3. These for file 1, file 2 and file 3. This is my first file name and opening it in read mode. Then if my file read is -1, as said previously, my file does not exist. If my file exists, I will read my file with the file descriptors and buffer and with size 100. So I will display my contents of the first file here, and then similarly for second file also I will do the same using the read system call and then displaying. So then I'll be storing both this read in S1 and S2. This is S1 and this is S2. So I'll be storing it in S1 and S2, and for concatenation I'll be using the plus operator. So plus stands for concatenation of the string, since S1 and S2 both are integer. So I will just concatenate it with S1 and S2. So the result will be stored in S3. So then I have to enter my new file name, which is F3. Then I have to create a file descriptor for that by using the create system calls, that is F3,0761. Again, 0761 is octal permission. So 0 stands for no permission, 7 for all permission as said previously. Then I have to write those contents in this third file. So I have to use the write system calls 1 and 2. Then I have to close the third file descriptor. Then again I have to open with the read only. Then I have to display my contents of the file by displaying my buffer3 array. Let's have a look on my output. So initially my hello 3.txt, as you can see, it's empty. I'm compiling my program. So my first file name is hello.txt file. The contents of the file is hello welcome, and my second file name is hello2.txt. So my new file name should be my hello3.txt. Initially it was empty. Now you can see hello welcome and hello welcome both are present. Let's have a look on it. As you can see, hello welcome and hello welcome are printed over here. So now moving to the third program. To write a C++ program to append some data to an existing file using Unix system calls. So it's very simple. We can handle only one function, only one file over here. So only one file descriptor can be used over here, and then I have created only one buffer array. Then this for input stream, and for file stream I create array of characters. This is my file name which I am getting to the system. Then I have created an open system call using the file name and the read write mode. And here, say before, this for file does not exist for fd is equal to -1. If it is not equal to -1, it will perform all these functions like read system call. Then it will display my contents of the file. Then I will take my input stream, the additional contents I have added. So it will be appended in that my previous file, and then I will display it. So when I take my input, then again I have to write. So I'll be using the write system calls using my file descriptor and the input stream, and this time I'll be replaced with my size as 50. So the contents of the new file is, then I'll be printing it with buffer. So it's compiled. Let's have a look on output. So my file name is hello.txt. So additional content. So earlier it was hello welcome. Then let me say it's thank you. So the content of the new file is hello welcome, and then the next line we have thank you. So this is our the required output, hello welcome. As you can see, thank you is in the next line. Now moving to the last program. To write a C or C++ program to randomly access a file using Unix system call. So in this program I have created a different Unix system call using menu. This is my CPP code. Sorry for that. It is in C language, so I have to use .c. So the C language have included all those header files, and including sys/types.h and sys/stat.h and fcntl.h. So fcntl.h is for unit system commands. So as you can see, I used an infinity while loop for my manipulation, like create, open, write, read and close. So the user have to enter any of these choices, and when you enter the choices, the switch statement checks which in all cases it matches. If it is 1, it will create a file descriptor for that using the file name, comma, the local permissions like 0755. So 0 stands for no permissions, 5 for all permissions, and 5 for read and execute. So in that case, my file will be created with fd, and I will display my fd which I have written to the create system call, and I will break my case. So, and then if it is my choice matches the second one, again I will be opening with read write mode, and then I will be printing it in fd. For third, I have write system calls. Since I have to write, so I will be using the write system call with file descriptor and my array of buffers, then the string length, like the size of my buffer. And then I have used my else system call with file descriptor, 0, 0. And for read system calls, I have used read system. For read system call, I have my fd, buffer, and size of my buffer, and then printing my buffer. And for close, we have simply used close of the file descriptor. So I'm compiling my program. So I have to choose create, open, write, read, close. So among these options, I prefer now 1. So file is created with fd3. So this time I chose 2. So you can see the file is opened with fd as 4. Now if I press 3, you can see you have to enter some data. So I prefer hello. Now you can see the bytes written is 5. So hello. So there are 5 bytes here. Now if I enter 4, it has to read. So you can see the output is hello. Now if I want to close, I just press 5 and it will terminate with 4. So this was my 7th experiment on system calls. Thank you for watching my video.